Hello, everyone. Today we're going to go ahead and talk about properties of limits. Okay. For Arduino, and my screen might be in the way, so let me go ahead and hide that real quick. Okay. So what we learned last week is these approaching a limit with a graph. So if the limit is approaching to a value from with a little minus sign on the exponent, that is approaching from the left. If the limit is approaching with a plus sign on the value, that means you're approaching from the right. And if it does not have a minus or a plus sign, that means you're approaching from both sides. Okay, so let's go ahead and look at this one right here. The limit as x approaches -1. So we're looking at the value of x equals -1. That's right here. And we're seeing what happens as I approach from the left, right, and from the right. So we can see that this gets really close. And we can go ahead and see that the limit is going to be this y value at that hole, so it's going to be a 1. Okay, that is very different to what's asked of you if they ask you, hey, what is the y value at x equals -1? Well, when x equals -1, it's this solid dot right over here, and that's going to be 1, 2, 3 in height. Okay, so go ahead and pause the video and give these a try. Okay, we can see that there's a little plus sign right here. So as x approaches -1 from the right, we can see that it gets really, really close to this y value of 1. And as x approaches this y value of -1, my y value is this 1 as well. And we knew that because the limit from both sides was 1. That means from the left and from the right is also 1. Let's go ahead and try this one at x approaches 2. As x approaches 2, this is 1, this is 2, so this is the x value, right? So we want to find out what happens as I approach from the left and what happens as I approach from the right. So we get to see that from the left and from the right, my y value goes to this right here, and we can see this is a -1. F of 2, however, we go ahead and find out where is the actual point for this, and we can see that nowhere on x equals 2, there's a solid dot. So this does not exist. Okay. As x approaches 2 from the right-hand side, remember this is as x approaches 2, right? From the right-hand side, we get to see that is a -1. And as x approaches 2 from the left side, so going this direction, we get to see that the y value is this one, -1. Okay, so hopefully that's a good review for what we saw last week. If not, I have a previous video that you guys can watch, and I actually did it on Pear Deck. Okay, looking at this week, we'll be working with limits a little bit more and working our way up to our calculus in-depth stuff. Today, we're going to be doing something fairly simple, learning about properties and direct substitution. Okay, so go ahead and take about a minute to pause the video and write down these notes. Okay, alrighty, so we're going to be talking about the properties of limits. So if we have a function that approaches a certain value, so let's say it's some function we don't know, approaches a c, it gives us this limit L. And if we have a different function that approaches value c, it gives me this limit k. We can go ahead and do certain things with it. So if you're multiplying a constant times a function, you can actually factor that out and multiply it times the limit. Okay. If you have two functions being multiplied by each other, you can evaluate them and then multiply the limits that you obtain. Okay. Similarly, if you have a function raised to an exponent, find that limit first. You can find that limit first and then use the exponent. One of our favorites will be to add or subtract and to divide them, which means you can just add or subtract the limits that are given or divide them. Keep in mind, we still do not know how to divide by a 0. So in this case, we cannot have g of x be equal to 0 if we're dividing by k. Okay. All right, so let's go ahead and begin. So for the first example, something that you might encounter is when they give you some function approaching a limit, so say 7, and some function g approaching 7. Notice how these gave you two different numbers. We're going to go ahead and try to use our properties. So the first one says, if you have 4 times a function approaching 7, right? Because we only know what happens on both of these functions when it approaches 7. We don't know what happens when it approaches 3 or 12 or negative something, only 7. So we can go ahead and evaluate. So f of x is 3. So 4 times 3 will be our answer. So our limit of f of x was 3 times 4 gives me 12. If we are subtracting 2 of these, we can actually evaluate the limit as it approaches each one individually and then subtract them. Oops, very bad handwriting. Okay, so as x approaches 7 on f of x, that is 3 minus whatever the limit is as we approach 7 on g's, which is 5. So that will give me a -2. Okay. Similarly, these can get a little more complicated, but it's overall the same thing. So we know the limit as x approaches 7 for f is 3, so it's going to be -2 times the limit of 3 plus 4. So this gives me -6 plus 4, which gave me a -2 as this answer. And something I mentioned a little bit earlier was we only would know what happens at 7. What if they told us 3? Well, according to this, we don't know what it is, so we're going to have to go and say undefined. Okay, we have no clue what happens in this function at 3. Okay, awesome. Let's go ahead and try one more. Similarly, if they told you, hey, what happens as the function approaches c? We're still doing the same idea, right? We're trying to find out, okay, we only know this function at c, which is 4, and g gives me -5. So all you're pretty much doing is adding these limits. You can split them apart. Limit as x approaches c for my f of x plus the limit as x approaches c for g of x will give us these individual limits of 4 plus -5. Whoops, -5, which gives me -1. Similarly, we can do this with multiplication, split them up, find out that the limit of f of x is 4 times the limit of g of x as it approaches c is -5. So 4 times -5. That gives me -20. Okay, awesome. Alrighty. So what I want you guys to do is actually practice some of these. So I gave you some very similar ones just to put in that practice. And then by substitution, which we talked about earlier. So if you have a substitution as x approaches 2, you pretty much just substitute the 2 into that variable. So it'll be 2 over 2 plus 3. 2 over 2, no, that's 1 plus 3 gives me 4. Okay. So pretty much that's what we'll be doing. So go ahead and complete these 4 examples. And then we'll go ahead and I'll go ahead and meet you guys in class. Okay. If you have questions, please reach out to me. And as always, guys, this has been a pleasure. Bye-bye.